Hi, thank you so much for having me. It's been a long time in the making, and I'm very excited to finally join you and the group. I wish I was in person. Let's hopefully make that happen in a not too far away future. Okay, so I wanted to present to you. This is brand new material, so it's kind of like already on a test drive. So let's apply all of the stress tests and see how it goes. It comes from a recent identification of problem in AI that I find it to be very colossal, and I wanted to share that with you, and hopefully get us to think together and see if I'm onto something here. So again, it's not a paper yet. It's what I've been putting together in a project, in a grant. Okay. So I'm going to highlight or try to explain where we find these kind of like reduction reinforcement loop in specifically machine learning. Okay, so let's do it. So then we start from, of course, a very wide understanding that as we all know, AI is everywhere, including in your mind. So that's what we're going to kind of like target most specifically, but it does not reduce to the mind. It can also be found in systems themselves in AI. Okay, so here I was thinking about the ways in which interacting with artificial intelligence systems of whatever kind can be interacting with self-driving, can be interacting with large language models, is going to be shaping cognition in general. Is going to shape cognition more specifically in our cognitive diversities, cognitive skills, creativities, as well as cultural epistemology. So thinking here of diverse epistemologies, and in our ecological connectedness to the natural world. So I encapsulate that, or I tag that, and the cognitive ecologies, that's what I refer to whenever I say cognitive ecologies. I mean these epistemology, cognitive diversity, and connectedness to the ecological world. Okay. Now, I wanted to make way to where I really want to identify that core issue. And making way for me means that I want to take us from and saying that it's not really on the level of the extended mind, as we know, Andy Clark and David Chalmers, but it's more in the sense of AI as a cognition shaper, right? So it's more how I'm thinking about it. So I'm moving a little bit away from the view of AI as that kind of like optimistic thing that allows us to use those mediators in order to interact with the world. I'm more thinking about, as we interact with the world, how does that is going to shape cognition in very much in line with works of Donna Haraway. Okay. So there is a bunch of literature on that coming from embodied cognitive science, or e-cognitive science, which I'm sure you're familiarized with. But for those of you who may not be familiarized, in e-cognitive science, the E stands for a bunch of E's. It keeps going and increasing. But it's basically embodied, enactive, extended, and embedded. There's also ecological, coming from ecological psychology. So here I've got just a very small sample of this literature, but just to really highlight that the ways in which technology shapes and is shaped by human interaction with it as they interact with the world is something that is highly studied in embodied cognitive science, and these problem of like how it shapes cognition, really something that comes very prominently here in tool use, tool interaction, and those kinds of things. Okay, so then coming from that literature, first premise will be that life is embodied, right? So I'm not thinking in terms of, like I said, the extended mind, or I'm not thinking about a computational framework or framing of understanding the mind. I'm coming from and I'm thinking about it in a very embodied kind of way, which allows me, at least to my understanding, it allows me much more scope to explore the ways in which cognition is shaped and shapes through interaction with these tools and specifically with these AI systems in ways that a computational theory of mind would not allow me to. So life is embodied, and here the kind of like slogan for this that I find amusing is to put it like, I interact, therefore I become, which is the Simone de Beauvoir-ish kind of like slogan. And we find here two illustrative papers where we can find that taking place, coming from like a strong embodied position, and thinking about the ways in which these interactions with these systems are not going to be simply in terms of a computational process, like Andy Clark would have it, for example, with the extended mind, but it's more in the sense of, and that's why I brought this paper to you, in active artificial intelligence subverting gender norms in human-robot interaction, just to give you the intuition that what I'm talking about is, this is a paper on the smart assistants, and what happens there is that the prolonged interaction with these smart assistant devices is going to be take the form of also educating, right? Because as we interact with these devices or these softwares, they are already they come with certain gender norms embedded in them, and in that case they're going to be very educational in the ways in which the feedback is going to happen, the things that are going to be said. And I do have this little square, I'd blush if I could, which is an initiative from UNESCO. And that's a program that they started because it's an interesting, funny story that was coming from Siri. In 2021, at the data we were writing this paper, Siri was still responding something like this. If you would tell Siri, hey Siri, you are a slut, Siri would reply, I would blush if I could. So then that's the program that is trying to close that kind of gap. So this is what I'm referring to, which is those kinds of like very highly situated interactions that are really hard for us scientifically to tackle and get a grip on, but they do exist and they are shaping. So that's kind of like what I have in mind when I'm referring to this. Okay, so now I wanted to move to trying to start now analyzing in what ways does AI and our interaction with it, be it more explicitly coming to our awareness or not, is going to be doing that kind of shaping that is a little bit of like an upscaled or an upgrade level of that kind of shaping. So we're going to move a scale up, and it's not going to be just the shaping that I just mentioned with Siri. What we find with the system itself or the model itself with, for example, machine learning, is a filtering out, right? So it's not just that it's the interaction itself that is going to be shaping, but the things that are going to be available to us to interact with prolonged in time are going to be coming from a very specific machine learning condition for it to actually be good, which is, or I call here, AI filtering out, right? So this is like one level up. Okay, so this is we have the best people, the most brilliant people tackling the AI problems from multiple angles. And from this point on, what I really wanted to point out here is that this is this multidisciplinary work. I want to show where they are sitting in tackling the particular problem that I'm after here. And then I wanted to show you and think with you that it may be mistargeting energies. Of course, not in a very objective way, but just let's see if we can make some progress on that. So we have, for example, AI ethics, of course, targeting many problems at different scales of an AI system. For example, in algorithms, right? Then we have epistemology, targeting echo chambers effects, right? And then we have philosophy of mind, like Susan, going all the way for thinking about interactions of machines and machine intelligence and human cognition. And then we have indigenous protocols and stances for artificial intelligence, which take a completely different approach that I think it's more, I'm more aligning with that vision here, because I'm going to be calling a little bit more towards the dismantling of the AI techniques, because they are the ones that are by default problematic. And then we have feminist technoscience, where that situates the literature that I was just showing you my paper on those gender biases in those kinds of like AI softwares, such as the work of Haraway. Okay, so I wanted to show that the ways in which AI is going to shape cognition is not a glitch, right? So I think that that's the message of this talk, is that it's not a glitch. And once we overcome thinking about it as a glitch, then I think that we're going to be much more well positioned and much stronger to make some real progress on what the issues are that all of this multidisciplinary approach is tackling head on. Okay, so I wanted to say that all of the kinds of issues that we're all very aware of and challenges that come in AI, they are by design, right? And I know that this is a quite strong claim, but they are by design. And that's what I wanted to show you, that that's where my research is leading me, is to this view that it's not only that they are by design, but a more recent development that I've come across is that it is also going to act as Murphy's Law. So it is always going to be the case that the system is going to behave like that by design. So that brings us to a really core problem. Okay, so we have this, what I call here the machine learning rule, right? So the machine learning rule is the one that is going to have the property of a Murphy's Law, right? It's going to be, that's the rule, and there's not going to be any deviation from the rule. The system is going to behave like that. The system is going, for it to be successful, it is going to be going by that rule. All right, so then the claim that I wanted to make, which may sound a little bit strong here, is that the machine learning rule, actually, the metrics for its success, the metrics for the success of machine learning, is that disembodiment is what is going to drive a machine learning process, right? So disembodied comes to be that metric of success. And I will unpack that in a moment, but this is just to really like bringing that clear, that that's kind of like where my thinking is at. Disembodiment is that metric of success. The unpacking of that is that the more a machine learning filters out embodiment, and by embodiment, again, I mean those cognitive ecologies, like all of the worldly stuff, right, that is meaningful to us and makes experience meaningful at all. The more that it is going to filter out those aspects of human experience, and by Murphy's Law, it will, then the more successful the machine learning is going to be. And it's going to be extremely successful, like breakthrough, really successful. But the problem is that it is one of those cases that you can continue playing it, but you're going to start losing things that are really, really relevant to us. So that's the thought there, and that's the kind of like a message, or the core message of this talk. Okay, so let's look at exactly kind of like strip apart the ways in which a machine learning model operates, right? It's going to have 4 phases, and many of you might already know that. It's going to have 4 phases. So it's going to be doing one thing, which is extract. It's going to be extracting data from the world. It's going to be then compressing that data by commodifying it, by stripping away. Here is where the filtering out starts happening. And then it's going to be doing something really important for the learning part, which is the standardize. That needs to be done. And then it's going to deliver an output that, in comparison to what we had before, it's a commodification, where what you really get on the other side is a disembodied unit that the model is going to be able to operate with, right? Okay, so those are the preliminaries. And I wanted to just give you an example of what I mean of this filtering out, and why does that matter? What is it, right? That I'm here saying that it's really important, this worldly stuff that we lose, and the more we play with it, the more we lose. So let me just give you an intuition for it. I was born in Portugal, so hence why I'm using this example, because it's my other second language that I understand really well. So in Portugal, we have a word for a word that is called saudade. That is the word is saudade, and this word has no translation into English. Hence why I selected this one. It's untranslatable, and you can put it as like an untranslatable echo of what's lost. And the quiet defiance of what remains, a melody woven from presence of the absent. In the hands of women who have known oppression, so that is resistance. So you can see that there are several layers that is not really possible to, translate it immediately. And of course, as language goes, or as Wittgenstein would have it, as language games go, a language is a living institute. So of course it comes with these layers. Okay, so now let's say that machine learning is going to do a data search on this word, and it's going to look into online dictionaries and encyclopedias for definitions. And then it's going to look into literature, poetry, song lyrics for the use, and it's going to look in social media for this contemporary usage, right? So from an ethics perspective, or from a developer perspective, one might be quite happy, because, it's going to multiple sources. It's going to go to, encyclopedias, where you might have like the older versions and interpretations and uses of it, and then it's going to go all the way to, a more contemporary kind of usage. So it's quite diverse. It doesn't really seem to have any issue. Now, the problem is that there's one first level, which is that this data is already in itself a reduction of the lived experience of saudade, or even, dare I say, of the knowing when to use and how to use this word, right? So this is a description. And as a description itself that I just read to you, it is not us utilizing it and knowing how to use in that particular language game. It is a text about saudade. So it is not saudade itself. In a way, we already have here a component of at least one level of dimensionality reduction. And then the data is inherently going to become disembodied and decontextualized, right? So that's kind of like the process happening. And then what we get on the other side is that, as I termed before, a disembodied unit. So then what we have here is a common, very standard common machine learning process, which is like you need to do the model building, which means that you're going to have to go and standardize and compress. And that means the 4 stages: extract, compress, standardize, commodify, and then rinse, and then we have machine learning. Now, let's take this one level deeper, right? And see where problematic things, or things that I find that are important for us in cognition will get lost, right? So let's say that for the first step, when we are extracting the data, we can call this level cognitive extraction. And here we can have in mind what I mentioned earlier, cognitive ecologies, right? So here I'm talking about the things that are going to be like cognitive diversity, epistemic diversity, as well as ecological relatedness or connectedness, right? That's the disembodiment of those things. Okay, so then here we're going to have one first level of extracting cognitive patterns from text, like so that one. And we're going from that, do some sort of interpretation or extraction of behaviors and cultural artifactoring lived experience into some quantifiable data points that the model actually can work with, because the model cannot work with high levels of complexity. So the model needs to do this. And then we have on level 2 model, we need to now, create that model. And that is going to necessarily require that we now compress what we had before as like high levels of complex patterns. Then for efficiency purposes, we are going to have to reduce that nuance, context, and individual variability. And that's going to have to be discarded. And we can call that like a cognitive compression. And then we have the third layer, which is now the learning part of the model. So then here the model is going to be doing something that is where we find that reinforcement happening as well, which is that the model is going to be doing one thing and one thing alone, which is following one rule. And here is where the rule is really, really important. The rule is that it is going to have to be optimizing for accuracy. And this is going to be extremely relevant. The model is optimized to find common patterns in the now compressed data that is reinforcing existing bias and creating standardized models of human cognition. So here, when we think about bias, it's not just that the data in itself was already biased, but it's also that now it has been removed from anything that was like could be relevant for a fair assessment of some particular content that the model is now working with, right? So then what is going to be happening here is that filtering out, right? And the reason that it must happen here as a meta of a Murphy's law is that if it doesn't happen, then the machine learning system is not going to have any value for us. It's not going to do anything that we expect it to do, which is to have, now going to the fourth step, a prediction that is accurate, right? So then we need to optimize machine learnings by default. They need to be optimized to filter out these things, right? So, so as much as one would be careful to, okay, what's the data? And the data sets that we're going to feed the model and train the model with, right? Of course, that's relevant, and we shouldn't lose sight of that. But that alone is not going to solve the problem, because by design, the machine learning system must filter it out. Otherwise, it can't do anything with it. So that's the step that is really required by definition to get a good, successful model that is going to predict accuracy. So now, in a nutshell, the accuracy success is fully dependent on the filtering out, right? Otherwise, the model is not going to be able to do anything of what we would like or find useful. The problem is that for the model to do that thing that we find useful, it is asking a lot from us in return. So basically, in put it in very simple, there's no free lunch. So what happens is that in this particular kind of like use of these models, it is going to be reinforcing these particular kinds of biases that in the end, the question is it going to be useful for us at all? Or is it going to be useful in the short term? But then when we think about cognition in particular, in the long term, and I don't know, something like obligations to future generations in terms of cognitive, cultural, epistemic diversities and connectedness to the natural world, then this is not it's asking too much, because that's the trade-off of the system itself. So the point being, and this is the crucial point, the point being that a machine learning model must always trade optimization for accuracy for adaptivity. So the crucial point is that this is a system that is not capable, doesn't have any additional system that it could bring in to deal with new information. So to put it in a different way, a machine learning system is going to be as adaptive as what it is possible within the training model. So this is highly problematic, because what then is going to happen is when we have self-driving cars, for example, if there's like a slight different side road that the car does not recognize, then that is not, the system has no capability, possibility to deal with novelty. It is going to be very, very, very accurate, and it's got really successful performances within the data that is being trained off. And then we can think about like other examples, like in healthcare, right? So when you have like a slightly deviation from initial conditions, like a slightly deviation from the data that the system is able to recognize, the system is not going to be able to make anywhere near an accurate prediction, because it has no capability of doing that. An intuitive example is that if we have a toddler that is presented with a fruit that, let's say a peach, that the toddler has never seen before, the toddler is going to interact with that. He's going to try to find out what's that in front of them, and eventually he's going to easily find out that, oh, this belongs to that category that I already know. So that those are the things that it belongs to. But the key point of the story is that it's going to be interacting, right? It's got this grounding, it's got the thing that I mentioned, the embodiment, right? So it's the embodiment of being in the world that is going to be able to allow us to learn, develop understanding. And if we would ask a machine learning to do that, can't do that. So then what happens is that even though these systems are highly successful in predicting accuracy within what they've been trained on, they don't have capabilities of a toddler. So that's the point that I wanted to make, right? And the same goes for self-driving as well, because what happens is as we are driving, we're able to hold multiple levels of tensions, right? As we are, seeing the car at the front, looking at people in the sidewalks, and driving the car itself, we're able to hold all of those levels of complexity and able to understand novelty, right? And machine learning is not capacitated for dealing with novelty, and that's why it is trading off accuracy for adaptation. So that's the point that I wanted to point out. Okay, so now this is I just wanted to mention this real quick for anybody that is anywhere near this literature. Just wanted to make that quick point, but it's not a main point in my talk. But I wanted to make this point. So it sounds like we are in a position that we can, if we are understanding, machine learning's challenges, like this one, and by the way, the one that I just explained to you, is the one that is somewhat kind of like dictating the kinds of like research programs that are really popping out in artificial intelligence. Most of them are to precisely try to deal with and resolve this problem of trading accuracy for adaptability. We don't have a solution for that. Many suggestions and strategies have been implemented, and they are not good. And here the point that I wanted to make is that it may very well be the case that what we are finding in machine learning, as we had a breakthrough in AI, it can very well be the case that it can inform to the limitations of the predictive brain. And by limitations, I don't mean technical limitations. I think that we've learned so much about the brain because of predictive coding. But it may very well tell us that it's a model that has got some constraints, a constraint being that it will not really deal very well with that, with adaptability, but it's going to give us a lot of accuracy. And I think that's, if we understand that, that's already, I think, a gain, because we understand the limits and the limitations of the techniques. It's just a side point. Okay, so then next question for me at least is, what happens when systems designed on machine-like principles are going to be reshaping human cognition? Because now we are going to be facing a second level problem, right? This is going to create us not just a technical mismatch where we're going to be like, okay, so we're going to have some safety concerns because self-driving cars are limited for this, and any other implementation with machine learning is going to be limited by this particular problem of filtering out information and then not having a system to deal with adaptation. But there's a second level that that is relevant, which comes through and is novel and comes as a new set of problems that come with large language models. And that's what I refer to a self-reinforcing feedback loop. And what I mean by this is that what is happening is that we have the machine learning doing the thing, right, following the rule and doing that extraction, that filtering out, and then delivering those disembodied units, right, those classifications as some form of units or units of knowledge that are now going streaming into our broader societal domains, from education-mediated AI to decision-making processes that are made across our society, as large language models, of course, are becoming ever more prominent and mediating those decision-makings and those educational systems, right? So then the question here is that if there is this filtering out, and if you're using machine learning, there will be a filtering out because it's necessary. So if there is this filtering out, then what is being kind of like fed back into our societies for decision-making, knowledge generation, is going to be these kinds of disembodied units that, as much as careful we are with data sets, and for a long time I thought that was something that we really needed to look into, but even if you do are very careful with that, it's a problem by design. So that's the point that I wanted to stress with this talk, is that gradually is going to be having this self-reinforcing cycle where the AI systems are going to be extracting those ecologies, right, and then feedbacking disembodied units. Okay, so I'm going to skip that slide. So then what we find this in different levels of society. For example, in cultural representation, in diverse perspectives becoming invisible, which is something that we are all very aware of. The key point of my talk is to say that, as much as I have believed in the past that if we were regulating for very good data sets, then that problem would be like somewhat a little bit more successfully resolved, but I don't think that's the case anymore. So that's a problem that I think it's not if, it's a when throughout time. Then we have also in virtual reality experiences. Then we have in AI-mediated education and public policy and anything else where we find any machine learning model doing the thing. Then we're going to find that that problem. Okay. So then, just a very preliminary overview. It is preliminary. So on why current approaches are going to be failing addressing at least these problems. I'm not saying that they're not useful whatsoever. That's not what I'm saying. But what I'm saying is that this is the root. This is the problem that needs to be talked about and discussed, is the problem by design, right? Because we can do some patches, but if we don't, okay, so the metaphor that I sometimes use is that, look, if you have a very unfair judge doing the decision making, right, you can do all of these like different strategies to come and bring more data to the unfair judge, or come and put like a person that is like really ethical next to the judge. But none of that is going to really solve the unfairness of the judge. You really need to change the judge. So that's the thought here, is that if it's a problem by design, then we really need to change the judge. Okay. So when we have, for example, a problem that we might want to start discussing, should this be the root cause that we want to be addressing, then the state of affairs is clear. There's a fundamental design misalignment in goals, right? So what we have is, we have theories that are more pushing towards prediction and others more pushing towards engagement. And I think that everybody is really aware that engagement is necessary to get out of or at least to try to solve the adaptability problem in AI. Engagement is important, and everybody's aware of that in many ways. Well, one of them being the frame problem, the grounding problem. It's that we don't get a system that is encapsulated, or as in working as if it were a closed system, to get that direct access to the world that would otherwise allow it to precisely adapt. So that's kind of like where we find that misalignment, and sometimes it's not that there is a profound misalignment, it's just that people doing the development, they don't have tools that would otherwise, that's exactly what they're trying to develop. Okay, so then we have another misalignment is to conceive of what AI could be as either a closed system or an open system, right? So then we have most, I can even try to make here a universal. Machine learning is a closed system, or works under the assumption of those closed systems. To the extent that what I mean is adaptability is it's perfectly the system can do, or this is exactly what the system is really good at. Adaptability is perfect within the training data, but not outside. So here we have a little bit of like for those of you more into philosophy of math and Kurt Gödel incompleteness theorems, here is where we find it, right? Is that the system cannot prove itself outside of the system itself. So that's the Gödel theorem plays here. Okay, so that's the problem, is that we are taking the system as a closed system because of the limitations of our techniques. But what we really would need to do to have a system that adapts is a system that is embodied and understands in the real time, the real world, in the present moment. Okay, and then we have another misalignment between asking for performance versus asking for ecological impact, right? So success in machine learning is measured as per this embodied of cognitive patterns, because it has to. It's the limitation of the technique, as opposed to what we would potentially all agree on, that we would need to have something that is more situated, more relating with the environment, in order to precisely do what we do so well, what toddlers do so well, which is to adapt, to recognize a peach, even if it's the first time that is presented to us. Okay, so then another one is the incompatibility of philosophical foundations, right? So here we find it's much more complicated than what I have here. I am working on this as well. If anybody has keen, I'm very, very, very happy to brainstorm on this. So there are fundamental philosophical foundations incompatibilities. And one is that most of AI systems, of course, the technology itself is going to be dictating, but most of they endorse good old mind-machine metaphor coming from the early days of AI with Turing machines. And then we have representationalist ontology, where comes or follows from the mind-computer metaphor. And that will then put us to think about how can we conceptualize AI? Well, then we have this kind of like framework with kind of like static learning models. And by static learning models, I think what I mean is that kind of like closed system kind of thing. I'm very mindful of the time. So then I can just like really here present in this slide that ethics, although ethics and governance are really, really important, the problem is that they cannot fix a technical problem. right? So if we have a technical problem, we need to tackle that technical problem, right? So that's the point. Super useful, but they can't help us with the technical fixes. That's the problem. Here was my attempt, very preliminary attempt, to kind of like spread out where the different approaches are tackling. But the key point, because I didn't succeed, the key point is that we tend to be tackling levels of the machine learning process, right? Either the input, either the model itself. So we have lots of developers trying to really improve the model to make it like able to balance between accuracy and adaptation. And then we have others regulating what is used by virtue of having those models. But the point is that it's like kind of like spread out, and I don't find that other than the developers developing AI, we are not really tackling this problem, and we're trying to fix an unfair judge. So that's kind of like how I'm seeing this. Okay, so then the path forward, I would say that would be like something along the lines of abandoning, so shifting from machine learning and designing something more in line with ecology's AI, ecosystems of AI. So something that is and learns from the natural world, which is a distributed complex system, right, where you have like a distributed intelligence, and where gain and risk are distributed equally, right? And you don't have that in machine learning, because what you have is a system that has got a concentration of a gain that we want to have, which is the optimization for accuracy, right? So then it's not distributed. So this is the design principle that needs to be in as we gather all of our minds to try to design something that would be much more interesting than what is limited currently by machine learning. So the path forward would involve a few things. I got here a few references of work that I've been involved with, which is for ecosystems intelligence, distributed systems. So all of these kinds of things that would allow us to begin to have a system that looks like an open system. And I think that that's really what we need to be aiming for, and our energies and funding and our brilliant minds should go into that, rather than trying to, fix something that by design is problematic. So that's what I'm kind of like sitting at the moment. And that would be, and I am wrapping up, and that would be actually retrieving the vision from Ada Lovelace, as she envisioned AI being sort of like a collaboration between the system and ourselves. So in that sense, it would be going back to our vision and trying to make it happen. All right, so this is my conclusion. Root causes are going to be the paradigm that is like underlying the early days of AI, which, for what was worth, it was very valuable at the time. But I think that what we can see from the ways in which we see developers really trying their best to be creative to really fix this problem, but it's just an impasse. It just doesn't go through. And I think that is related to the root cause, which is category mistake, and the problem of understanding what understanding in cognitive systems like living ones do have, that allows them to understand what speech is on a level of a toddler. And then it's the mechanism. So it's the AI that has got this flaw by design. And then we have another layer of complexity, which is feedback loops that are delivering these disembodied units to kind of like now train us. And that I find as well as an added complexity challenge that we really need to look into. And then we have intervention points that are opportunities. And that's, I think, where we should be concentrating our energies, like alternative success metrics. So for example, if you just start by saying, well, the success metrics cannot be accuracy for the sake of accuracy, because we know by Murphy's law that that's just going to be filtering out adaptivity. You can't have both, at least not within this design. And then also define some desired outcomes, like what would we like, what can we envision? There are conditionals for understanding what a peach is, that's what we want to be using for our, really thinking outside of the box, being imaginative, and thinking about next generation AI. Because the problems as they are with machine learning, they seem to be, if I'm on the right track and they're by design, as many have also, come to that conclusion, then it's going to be the case that a patchwork is not going to do it. So that's me. Thank you so much for your attention, and I'm very much looking forward to your comments.
Thank you very much for that, Ines. I will stop the recording there.